Hey everyone, in this short lesson I'd like to talk about this type of a vanishing effect, which is a quite a popular effect, which you may probably see in a different type of movies, um, and it's very interesting effect and easy to use, um, and also the it can be actually can be layered, so this way you can achieve some more complex results. Okay, but in this lesson we'll use the simplest one, and maybe in the next lesson we'll try to create something more complex out of it. Okay, so let's actually see how we can do this sort of effect. So here I have my scene already been set up, and despite this effect is being very simple, there might be small obstacles that you may face during the creation of this effect, like particle uh, view shape, or maybe a simple image, and also uh, not to not to overdo the effect, so it will not look as nice as it should be actually. Okay, so let's start with our character. So here I have an alembic character with idle movement, which I would like to apply effect on. So first thing, I'm unpacking my geometry, and then uh, uh, I want to do a small setup. Um, so here I'm adding cycling movement because I have only 100 frames of the animation. This way I have a cycle. Okay, the next thing I'm doing in this scenario, I will be using UVs as as a place of controlling uh, the disappearing effect, the vanishing effect. Okay, so I'm freezing my animation and I'm adding simple UVs onto my character. And next step, you can use either a point deform to connect uh, an animated character to your static geometry, or simply copy your UVs to your animated character and continue work from here. So I added two methods, uh, whichever you like you may use. Okay, uh, so during the creation effect you would probably would prefer to work on the static geometry, very simple geometry, so you can see your effect, the feedback very quickly, and do not spend time on waiting whenever it caches, especially if you have some movement or changes on your geometry. Okay, so here I'm using uh, the frozen version of the geometry. I'm adding some normals, do some cleaning. Okay, and then uh, I'm assembling my geometry, and here I have some packed objects, which I can easily do some selection onto the, because if I have the polygon geometry, I had to select by polygons, which is a little longer than if you're using an assembled object. Okay, so here you can fastly do selections. So here I am isolating the body, I mean isolating arms of the character, because I want some different animation on my arms, on arms of the character. Okay, so here I have the body, legs, and arms separated. Okay, so here I'm unpacking my geometry and subdividing just to have a little more details. And in this scenario, I'm using this asset which I created. It's not very complicated, but it helps me a lot in daily work. You can download it on my Boosty channel, or either you can use the simple version of that, which is free also on my Boosty channel, or you can create all those procedures by yourself, which is not complicated. There is some noises, being used noises, ramps, okay, and some delete point primitives applied to the geometry based on a color. Okay, so it's very simple. Okay, so here I'm doing a correction on my ramp parameter, and here I'm animating the offset of this parameter. This way I have, if I, for example, just duplicate this and kill the noise, so as you see, I'm having this stripe, a thin white line which runs over the character. Okay, and yeah, as I said, I'm using not the sorting operation, which I can also use, but I'm using the UVs of the character, which I've created before. Okay, so next I'm adding some noise just to give a variation, okay, of a particle placement. And yeah, that's about it. So here I have a full a full path of this white line walking on the character. Okay, and the second part of this effect is the disassembling, the vanishing itself, the mesh itself. So here I'm using the same setup with keys applied. I'm simply duplicating it, and I'm just deleting one side of the ramp parameter, just to have like from white to black straight, and I'm having this type of vanishing effect, which is a good effect by itself. Okay, you can use it without adding any particles. It's like a hollow man effect, I should say. And I'm adding some time shift to this effect, just to run this later, so I could just match the gap between this effect and the particle movement effect, so just to link them to look nicer. Okay, here I'm merging this both, because this one is set up the same way as I explained here. Okay, and I'm merging this also together. Yes. Next, we are going to our particles. The particle setup is very simple. It's a basic setup. So here I'm having my source, first context geometry with some particle count. Here we have this one 0 0, just constant activation, and some life changes. Then some force, I want them to move to the side by x-axis. Okay, some noise applied to the particles and drag by default. And also I'm adding some ground, so my particles, just when they reach the bottom, they could collide with the ground and just slide sideways. Okay, so here's the setup and a sub-step just to increase the detail of the simulation. So if I'm jump ahead to see the effect. Okay, so as you see, we have our particles movement sideways. Okay, and if I just do a straight connection to, say, let me add a null here. So we can visualize them together. So as you see, our particles are moving like we have planned. Okay, so here I'm just adding colors to visualize things properly. Okay, so after we have our points, let me turn this off for now. We would like to apply some geometry to see. We can render it as a points which renders, like, allow you to render like points or some spheres or whatever it is, lines. But here I'm going to use geometry shape. So here we have a lot of geometry. Okay, this is why I'm using here a circle with a minimum number of points, just to ease the simulation. Okay, and what I'm doing next, I'm adding actually a scale. Here I have a small expression which uses the age and life attributes of the particle, which is I'm using to compute the p-scale attribute, and here I have a ramp which allows me to control my p-scale attribute. Okay, using the age of the particles and a multiplier. And so here, by adding a p-scale, I'm having a control over those particles. Okay, so as you see, by aging they get bigger and then they just get small and vanish. If, for example, I will not use the getting small by the age, they will simply disappear, which probably are not good way of completing the effect. Okay, you want them just to get smaller, or just to get transparent over and over and just disappear, not simply like disappear at once, which is distracting. All right, and so here I have my particles being equal by the size. So I'm adding another p-scale, but this time I'm adding some randomness according to the point number. But I also, since I'm using particles which has an ID attribute, I could also use a ID attribute which is preferred in this case, because the IDs are constant values of the particles. Okay, but just to explain things, here I'm adding a p-scale and I'm multiplying this by some random value. This way I have a different size of particles, which gives some nicer look. Okay. Let's run till the end. Okay. So here, as I said, we have a contact with the ground, which gives a really nice effect of particle just sliding on the ground. All right. Another thing to explain. Let me actually increase the size of the particles just to see the just turn this off. Let's go back. That I would like to explain. Just to visualize the things I will create. All right. Since we have a plane particle shape, we have like different orientation of the particle, which is not preferred. You can use the sprites and render with mantra. I'm not sure whether you can render in Karma sprites at this point, but let's say I'm using a simple like 2D card geometry, and I'm having like them being oriented differently. Okay, what can I use? In my case, for example, in this case, I'm looking straight on z-axis, so I could simply use a normal, which is facing the z-axis, and this way you can see those particles are facing the axis. Okay, but what if we have a camera that actually face some different direction, and you have a different view? So what you can do in this situation, you can simply use your camera as the, let's say, let me object merge my camera. Okay, here I have my camera, and I would like to subtract my particle position and the camera position and use it as a vector. Let me import. Here I'm using the second input, and here I'm subtract position, and we are putting it into normals, and here we are promoting constant value. So as you see, our particles are looking into the camera. This way you can control your 2D particles just to face your camera. And this way we can use we can add some different images and create some, add this way a little more details to our particles, and also simplify the simulation process. Okay, right, let me just go back to all those setups and the value. All right, just all right, and the last thing you can also do, let me actually activate my cache. There's a little more points I've added. So here I also added an alpha, which use also this agent life attributes of a particle, and I'm controlling it, and I could use it later in the shader to control my disappearing particles to get transparent. Okay, but I turn it off because it affects my playback range in the viewport. And the last thing that you may probably want to add is the coloring of your particle by using this age attribute and using your approximately the maximum age. Okay, this way you can add different values to your particles. Okay, well, as you see, the effect of it's not very complicated. It's easy to set up, just a few things to control. And yeah, that's all I'd like to share. Hope you liked the lesson. If you find it useful, please subscribe for more upcoming lessons. And thank you very much. And goodbye and good luck.